All right, so I'm Jeff Choate and Matt Mitchell is to my left. We're Team Steinman. We've got Ross Phillips and David Stinnett still on campus. Deliverable 1, we discussed foundation training systems. One of the first things we did was found our occupancy. We came up with a total of 745 people, and this was based on several factors and assumptions. Over here to the right, this blue area is what we calculated our main square footage, where this was essentially 100% of the square footage went to our occupancy. This orange area where the rising floor was, where we discussed the fixed seating, we deducted 50% based on FEMA regulations, 361. And then we neglected the storage area to the right and the restrooms. Then we made the assumption of 5% of these people will be handicapped, so they require more square footage. And then based on FEMA, again, we subtracted 15% off the top for egress. Calculated our wind loads. Found that our windward pressure for 250 miles an hour, 183 pounds per square foot. And then on the leeward sides, on the long wall, 145, and the short wall, 122. We have some handouts that show our calculations.
They were uploaded to Google Drive. I do have some printouts.
Those. And these show all the coefficients that we use and formulas. Finally, for our design criteria, we looked at seismic setting. Based on the geotech report, this is classified in seismic zone 1, with the least potential damage. Also, based on the geotech report, we classified this in the rock profile, class B, and this was based on the EIT being founded on drill piers into competent rock. So down here to the right are our coefficients for seismic design. That's calculate our seismic load when we get to that point, based on our building weight. Foundation systems, we considered several options and then kind of detailed 3. So continuous footing, a mat foundation, and then 2 deep foundations for driven piles and drill piers. Continuous footing and stem wall. We looked at this as it's generally a lower cost. It is labor intensive though with the formwork and excavation, I guess. It can provide some uplift protection, and there's no special equipment or specially trained people to install it. In this setting though, we kind of eliminated it based on the shallow schools in the side. Mat foundation, another shallow. Again, no special equipment or personnel. Requires minimal formwork compared to the shallow foundation or the strip footing. More time efficient. One benefit of the mat foundation was ideal for construction that's sensitive to deformation. And so with a tornado shelter, if we're looking at concrete construction, this could be a benefit for us. But again, based on the geotech report, we ruled it out. So this is our selection, the drill piers. After our discussions last time, we went with the recommendation from the EIT geotech report. Can provide good uplift and lateral resistance. And then if we chose to use load-bearing walls, we can use grade beams to connect between the piers. Framing systems, again, we looked at several options and then kind of detailed 3 of them. So we looked at a steel option, cast in place, precast, CMUs, and then tilt up. So a steel frame system, using columns and beams, and then one of the big drawbacks with this type of frame is the void between your columns. You've gotta have some kind of, tornado missile protection. It is readily available, and one could be drawback is, steel is lightweight, so, 250 mile an hour winds in a tornado, that may be a drawback in this case. Reinforced CMUs, the biggest drawback on this is, requires skilled labor to install. And based on talking to some faculty and other folks, especially in the Little Rock area, that might be difficult. But another benefit would be you wouldn't need that additional missile protection if you went with this option. But then your cost is a little higher because of the skilled labor. Finally, and our chosen option, tilt-up concrete walls. They should be cast on the slab and then erected. These are easy to construct, pretty quick, low cost, less formwork and labor. Drawback would be you have to have a crane, which you probably have on site anyway. But so this was our option chosen based on load bearing capacity and missile projection.